How are you doing, my friends? Excellent. Are you done with continuity and differentiability, or just continuity? Okay, just continuity. I heard and both. Give you another minute. If you are confused or you want to know what I need to see, let me know. I'll be happy to clarify if it's not clear. Are you ready? Okay, cool. Today's lesson is an easy one. You will love it. You're almost done with techniques, all the definition, the derivative techniques I can muster, but you still have one, at least today. Logarithmic differentiation. Doesn't that just make you sound smart to say it? Tonight at the dinner table, they'll say, which one? Yeah, logarithmic differentiation. No big deal. Okay, it makes you sound smart. Am I right, Ella? All right. All right. That's if you actually speak to your parents at the dinner table, which you probably don't. All right, whatever. So here we go. Logarithmic differentiation is a way to make your life easier. And it's actually very consistent with what we've already done. Remember how we took the derivative of 2 to the x before you memorized it? How did you do it? You did what? Change the base. You took a log, I heard. That's true. We took a log of both sides. Why? Why log? Why not square root stuff? All right, there's an awesome log rule that says if you have a log there, the exponent can be brought in front. That's the reason we take logs. And so that's delightful because it deals with the variables in the exponent problem. After that, we then took the derivative and all that stuff, yeah? All right, now that same idea will be used today, except today, instead of a constant to an x, you might have a variable-based variable exponent. How do you reckon you take the derivative of that? What should we do first? Let's take the natural log of both sides so that it's not as ugly. Then let's use blank differentiation. Speak some calculus vocabulary. Implicit differentiation. What's the implicit derivative of the left-hand side? The y dy dx. And the right-hand side requires the product rule. First stays the same, x. Derivative of the second, 1 over x. Second stays the same, natural log of x. Times derivative of the first, 1. Cool. All right, so dy dx then is y times 1 plus log of x. And the other example, did we just leave it in terms of y, or we said, oh, the original problem's in terms of x, so I should put my derivative in terms of x? All right, so dy dx at the end of the day is x to the x. X to the x, 1 plus natural log of x. All right, you follow? Okay. Try then those 4 on your phone. These are all various, that's yucky kind of things besides the big idea. Walk around, if you don't want to ask what's going on, you got me. Yeah. Yeah, probably. Yeah, that's so. I don't want to take a lot of other things. Yes. Yeah, absolutely. No, absolutely. Yeah, I absolutely will. I obviously I showed every little step in the example, but you can definitely skip some of those steps in your homework. I just wanted to be clear. So, for example, moving the y over, then replacing it, that doesn't. Sorry. There, it's, yeah, you're right, it's not written correctly, sorry. Hi. Which one? Okay. So, this, so it makes this one R, what is that? Why does this usually apply this one? Yeah, that's, so this, the remedy to that is to say, well, what if it then you can do you can call it B. Yeah. No. All right. So, can somebody throw your first one out? dy dx is x cotangent of x as your log of sine of x. Is that about what we all have? Or something equivalent? Not at all? Okay, we'll talk about that one in a second. I'll come back to that. But for most part, we good on that one? Okay. Now, all of these, so just so we're clear, 90% of them are like that. It's pretty straightforward, right? These are gotcha, the worst possible cases I got from a really, a tough textbook. I just want you to be prepared for the worst. Now, this, I used to not think, I took data on this, and I put a question like this on the test, and I had something like 95% success. Cool. If I rewrite that same question as just, hey, what's the derivative of sine of x to the x? Now the success rate goes down to 40%. What's the problem? It feels like the same. Why is this one easy but that one hard? Yeah, there's no other side to take the log of. I mean, people say, what the freaking heck? You told me to take the log of both sides. There's not a both sides. What should I do? Well, you make a both sides. You say let y equal u to the cotangent of u. And that most definitely does not break math. That's creativity, not breaking math. And then you can take the log of both sides. So if you don't get a two-sided expression, make a two-sided expression so that you can do your thing. You with me? Yeah. So you get something like 1 over y dy dx equals, shoot. So this is cotangent of u. Oh, so gross. Nasty. What's the derivative of cotangent? First stays the same. Forget you, fool. One over you. First stays the same, derivative of second. Yeah? Plus. Second stays the same, natural log of u. What's the derivative of cotangent? Negative cosecant squared. If you don't know your 6 derivatives of trig, you really need to study those. dy dx is y would be back to u to the cotangent of u, and then all that stuff. Yeah? Are you with me? Okay. Now, all of these others have different yucky points to them. Let's go to this guy. What's the yucky to 3? What? Chain rule. Okay, so do you want to take the log of, first of all, f is, call it y if you want. I don't care. That is not an issue. So don't get triggered like that. Do you want to take the log now? Can I bring stuff down if that log is way over there, way removed from that?
No.
So what's the problem? U sub's too complicated. What's the problem? What's making your life hard? Tangent. What can you do about it? Get rid of tangent. Okay, so arctangent of y equals x to the 3x squared. Right. Now, are you ready for some log rule action? And now, if you take the log of both sides, then it's directly the log on that guy, and you're ready to go. The log of arctangent of y is 3x squared log of x. Again, I don't know if you need to write that. You can skip a few steps here instead of just saying it's down, whatever you want. But now we have to be on our derivative game here. How do you take the derivative of natural log of arctangent of y? 1 over inverse tangent or arctangent of y times 1 over the derivative, or 1 over the 1 plus y squared, and then dy dx, yeah? Equals, by product rule, first stays the same over the derivative of log, which is x, plus second stays the same times the derivative of 3x squared, which is 6x. You follow?
Yes.
So, dy dx, running it in for the touchdown, is something like arctangent of y times what? Bless you. 1 plus y squared equal, or times, the quantity, or sum. I'm going too fast. 3x plus 6x natural log of x. That's, yes. Yes, always. Okay, yes. Say that again. You could do that. Was that better? Is that what you did? Did that work better? It's absolutely 100% allowed. Whether it's better or not, I don't know. It's worth a shot. That's interesting. Yes, it would be fine. The last one was the one in the Saxon homework later on, and it tended to get people. What was the problem? First of all, here, this is the derivative of this whole thing. It's not just the derivative of 2x. So would you put brackets around that, please? Second, what makes this grow? The sign's fine. It's two things in the base instead of x. Okay, that makes things something even better. Doggone be prepared for. So here we go. Y is, we're going to start off with making it two-sided. And it is y equals 2x in parentheses to the sine of x. Right? Now what should I do? Natural log. Natural log of y equals natural log of the whole side. I have to erase this. Okay, cool. So Let's see here. Log of y equals sine of x log of 2x. Yeah, okay. Take the derivative now. Take the derivative. 1 over y dx equals cosine of x plus sine of x. And you say 1 over 2x times 2. We're cool. Yes? It should be cosine of x. Ben? It's just some, so it doesn't matter. I was just following what Ben told me. Ben said so.
That's the order I do it.
So for pride, I say first and second, and every other textbook actually says that too, but because it's some. For quotient. Okay. Are we cool with not being done? Good. Okay. So y is 2 to the x sine of x and all that stuff in there. Are you with me?
Yes.
Sine of x over x. Okay. That's one use of logarithmic differentiation, when you have a variable in the exponent and you want to take a derivative. Okay? Okay. The next is a wonderful thing. All right. If I said differentiate that thing, what do you think? Yeah, exactly. Say, no, I'm not doing it. You're an impudent little wiener. All right? Because you're saying, forget that, I got a quotient with some product rule and chain rule, two product rules, two product rules. I got some chain rule action in there. That is ridiculous. Rickman, you crazy? I'm not crazy. You can do it. How can you do it? With logarithmic differentiation. And you will need to write y. You're going to need to write y. So here we go. You're going to take the log of both sides. Log of y equals log of gross thing. Now that seems like a major step backward because you just seems like you almost made it more complicated. Yeah?
Yes.
And yet, my friends, on the right-hand side, I can now write it as
2 natural log
1/2 natural log of x minus 2 plus log of 2x squared plus 1 minus log of 4 minus x minus log of sine of x. Now I've blown up that big expression into lots of little manageable expressions. So if I take the derivative now, remember I've just been doing algebra so far. Now I'm ready to take the derivative. 1 over y dy dx is, what is the derivative of 1/2 log of x minus 2? Oh, really? You're so slow.
I was here.
You see, yeah, see, Ed's with me.
You split it up.
Me and, well, this is not No Child Left Behind. It's Many Child Left Behind. Yeah, so I used all 3 log rules at hand. First of all, I used the fact that if you have any kind of root, it's the same as a power, and that can be brought out front. That's what I used there. Okay. I also used the fact that the log of a product can be written as the separate sum of 2 different logs. That's why these are both added. And then anytime you take a quotient, it's actually the log of the difference. Now that said, anything in the denominator needs to be negative.
Okay, I think I get it. So if you took the numerator and instead just like talked about the negative root to be from -2 the sum, I think I get it.
Okay, okay.
I know how to.
So anything, basically I did this. Anything in the numerator is a positive log expression. Anything in the denominator is a negative log expression. And anything with an exponent or a root needs to be written with an exponent coming down up front. In that case, only the root. The only root was that first. Does that make sense? Okay. All right. So when I take the derivative, what is the derivative of 1/2 log of x minus 2? Over 2x minus 2. Plus, what's the derivative of log of 2x squared plus 1?
1 over x plus 1 plus 1.
Times
4x.
4x via chain rule minus
1 over
1 over 4 minus x. Don't forget your chain rule.
negative 1.
Negative 1, making it positive, and then minus 1 over sine of x times cosine of x, which you can imagine might be written cotangent in that answer key. So, last but not least, really this is just an exercise in how tough is your hand, because now you need to move over the y and replace it back. So, the y replaced would be root x minus 2, 2x squared plus 1, over 4 minus x sine of x, times 1 over 2 root, or 2 times the difference x minus 2 plus 4x over 2x squared plus 1, plus 1 over 4 minus x plus minus cotangent of x. See where I'm coming from? Okay. Shall we try one out the homework, or now we'll go to questions? That's an or question. Who said yes to an or question? Yes, you want to go over the homework, or yes, you want to do one on the homework, or go over the last one?
Yeah.
Do one off the. All right, let's do one. How much time do we have? We only have 10 minutes. Let's go to questions on your homework.
Sure.
5. 83. 5. Some up to 115. Maybe it's just 22.
Oh, Edith, I pay attention to what he says.
Okay. 5 and 22. 23. And what else? Okay, let me know if you have others. So 5, this 5 isn't replaced, is it? Yes. It is replaced?
Before he did.
Huh. Let me have 83 in front of me. Let me have grade 2, please. Okay, 5. Every year, about 2 months after the AP exam, I get a detailed printout of what question was most missed and what concepts were most missed. And usually, I mean, our kids do really well, obviously, but these are some that we could do better on. Okay, thank you. All right, so what does this tell you? What does Riemann sum tell you? Using estimating area by rectangles. Okay, this is the delta x of the base of the rectangle, right? So we're going by 1/3 in some fashion. I see a 1/3 there, a 2/3, and 1 obviously indicates 3/3. The question is, are these the right points or the left points? It says these are right Riemann sums. So if this is the right Riemann sum of the first rectangle, what did it start at?
0.
0. So the first thing is, this means it must have started at 0 and gone to
One.
1. And then in here, remember the heights come from the F at different points, which come from the starting point plus how many deltas over. Well, in this case, the function is obviously natural log of x. Follow?
Oh,
If it said left, what would the limits be?
no, 1/3 or just 4/3?
1/3 to 4/3. Yes. Summation notation. So that's part B, yeah? Okay, so in summation notation, we typically write this as f of x sub I. The 1/3 is just a straight up 1/3, and the function is the log of. So here's the hard part. Remember, the whole idea is counter kind of thing. And so it's not just log of I, because this doesn't count by thirds. It counts by ones. 1, 2, 3. So if I want the third to always be there, then it needs to be there, and the counter is I equals 1 through I equal 3. Not n, 3. Okay? Does that make sense? Cool. For the second one, surely the delta is a third again, and I'm seeing 4/3. I'm a visual person, so this helps me to draw a little number one, all right? If it says that the right, this says right again, yeah? Okay. If it's right, then that means this is the right side, which means I need to go back a third to where it started. What did it start at? 1, or 3/3 if you like, all right? So it must have been the case that it started at 1 and went to, did it go to 5/3 or did it go all the way to 2? It went to 2. What's the function? Square root of x, all right? In summation notation, again, just say what's always there. The 1/3's always there. The square root's always there. The divided by 3 is always there. What's the counter? Now the counter is 4, 5, 6. Now I just said, screw it, I'm going to call that I, and I'm going to start I at 4 and go to 6. Could you also have done some kind of shift so you started at 1? Sure. Is it way more hard that way? Yeah, it is. Okay. To me, that's easier. You follow? Okay. So that my point is there are lots of different possible answers there, but that's to me is the most straight. Okay. 22. Question on 22. 22. Very please. All right, so it says y is the variable of integration, right, definite integral of this. So x equals 1 minus y squared. I think you'll agree that's a form of the circle, yeah? But instead of the whole circle, if it's positive x's, what part of the circle is it? The right half. So it's only this half. Y of, as the variable of integration means the rectangles go this way, yeah? Okay, so when I go to find the area of this, or set up the area of this, the heights are dy, and the bases, aren't the bases just x? I mean, whatever the x is, but in y terms, so 1 minus y squared rooted. You follow? The function, basically. You with me? And then the other question is, what is the value of this integral? Now, to actually integrate this by technique, it requires some major techniques. You have to use trig sub, and you get sec and q. It's a mess, okay? Integrating that by hand is a mess. But luckily, we don't need to integrate it by hand because we have geometry. What's the area of it? 1/2 pi r squared, yeah? All right. What about 23? Is 23 still a question? Okay, is that book or replace? Book y equals the normal line to x minus 2 over x plus 1 at x equals 3. So normal line is just like tangent line, point, slope, except the slope has got some monkey business in it, right? So the point is when x equals 3, y equals 1/4. Do you agree? Okay, so 3 1/4. The slope, now this is the tangent slope, remind you, is f prime, and by quotient rule, low d high minus high below over the square of what's below, and we're going to do that at 3, yeah? Do that yourself. I'll do that also. I guess I could have combined my terms then put in 3, whatever. 4 minus 1 over 4. I'm getting 3/4 for that. Can you check me? Oh, is that what you got? You're right, I sure did not square the bottom. Thank you. So 3 over 16, does that seem cool now? Okay. All right, now that's the tangent slope. So what's the normal slope? Yeah, it's opposite reciprocal, and now we can write our tangent, our normal line rather, y minus the fourth equals negative 16/3 x is 3. Okay. Any other questions on ABC? Cool. Let me know if you have any questions. Yeah, perfect. There you go. Hi. Hi. Dude, come on. No problem. Thank you. Have a good day.
Alright, PCC hurts.
And I was trying to figure it out.
It's less than a Longhorn. 50cc, the game is actually fun, but up until that point, it really is. It's like me playing Mario Kart. It feels like only game mode I know how to play. When did you play like 200 meters?
Oh, that's here. That's the slowest character in Slurpee because you know anything goes wrong.
Yeah.
So I think, yeah, so that goes, that should be in because it's working. Yeah, work. It's in there. It should be. But it's, I think you're putting it into the slope of the sun. So you should, this definitely does need to be there, but this one is y updated. So y equals 2x.
Okay. But I'll get this eventually.
This is due at 3, right?
Yes, whatever. I will actually come back after the conference, so as long as it's here by 6. Okay.
They'll probably be here.
Okay, sounds good.
Sure, Sam.
Yeah.
I have a conference today, and then you have to do conferences, and I have to go do other stuff.
So rude. Okay, so what are you gonna do?
So I'm just gonna come home like for 7 hours.
Okay, sounds good. I won't count it late if you get in trade today.
Thank you.
All right.
Yeah, I'm in college, okay, so we can get at all. At that point, when you're in college, you either know where you want to go or like what you want to transfer into.
Yeah, you don't need to continue getting emails from colleges.
Well, and I keep getting emails from Classified, which is a military school. And my mom's like, yeah, you would pay for all your education.
Great school.
No,
Oh, it's a fantastic
no,
school.
West Point's great. That's everything my parents are saying. And I
Dude, George Washington, I mean, what, a fourth of the presidents went to West Point. It's the best leadership training school in the world.
Yeah, I want to be a leader. I agree.
Okay.
I don't want to have to like give it 5 acres.
I don't want to.
Like, no, no, Dad said it was no. My dad told me that's why you still have no.
Well, Holly is still getting emails, and now they're
Are you
like,
serious?
do you want to transfer?
Really?
No, she's been getting emails from other colleges, like, I'm happy where you are, Cal, transfer here. She's like, no.
I just assumed it stopped after you went to school.
Eater rat on her.
Oh, she's gonna get arrested disturbing.
Eater rat.
Apparently you scroll on the media. If I get there 10 minutes late, they're like, you're here. Like, that's perfect.
Uh-oh.
Should I speak to periods of BC
Okay. Hey, what's up? What's up, Dad? How you doing? Kind of wears off after I had a few guys on, but after a while. Okay, I want to talk about this one problems. Hang on to this one just a minute when you get back.
Don't even mention it. I'm starting. Today, Coach came by and said, well, I think they like my year better because it's like I hate to take time. I'm gonna say favorite because like such a such a no, I don't. We'll take from Bernier doesn't work.
Okay.
But then Tuesday for some reason.
I'm a couple days behind, so I know this homework was a couple days ago. There's a couple things I wanted to say. Just generally speaking, and strategy, and just some things to comment on. When I checked set 80, first thing I checked was number 4. Number 4, I know it's been a while, but you had some kind of maximize or minimize the volume of this thing, given the surface area factor. With me? Okay. Now, the problem is I had people write this and they said maximize. Forget that stuff. That looks like a hard derivative. I'm going to use my calculator. Well, I guess what's the name of this class again? BC Calculus. Not BC Calculator. BC Calculus. In other words, I expect you to actually use calculus to maximize something. All right? I, at the very minimum, expect you to show a derivative. When I went to grade this, I decided, man, these people should, come on. You take the derivative, you got your negative 2x here going on, you got your product rule thing happening, this is x squared. derivative of both at the same time. 2x root 48 minus x squared. Okay, now, the way I graded this problem was if at least you took the derivatives by hand, okay, I'll call it good. And then I had a lot of people say, forget that, I can do the calculus, but that algebra, forget that, I'll pick it on my calculator. And they used the calculator for that, or they just looked it up in the back of the book probably. I didn't count out for that, but I'm also a little mad at you. Shame, I know your name, all right? You should be able to work that through. This problem was from a CU Calc 1 test. You should be able to do this, okay? Now I know you're a little more motivated on a test than you are on a homework, but that's not terrible. So just so we're clear, and to convince me you could do it, if I just said solve the equation, the 0, would it be okay to clear the fractions and multiply through by root 48 minus x squared? Yes, it would, okay, because your main goal is to say where is it 0. And where this is 0 would be an undefined point, and so you wouldn't want to know that. But if you're looking for critical numbers, don't you want to consider what makes the bottom 0? So you really do need to keep that there. Calculus, good calculus knowledge says, because you want to consider, all right, undefined could be if that's 0, so I need that there. I don't want to clear that out. The rest of it then, depending on if you, do you mind if I just dump the 2? Okay, cool. All right. So the rest of it then is negative x cubed, and when I multiply this root through by the common denominator, I get 2x times the quantity 48 minus x squared. Stop me if you disagree. Are you with me? Okay. I feel like that was not too hard. Now if you said I don't have enough room, okay, you got me. Probably should have given me a little more room. All right. When I finally take this all out, I get 96x minus 3x cubed. Do you agree with that? Do you agree with that? Cool. All righty then. Wouldn't you agree that v prime is 0 if, what, 3x times 32 minus x squared is 0? What critical numbers does that yield? 0 and square root 32 or 4 root 2. All right, plus or minus technically, and I believe those are in the domain, so I think those are good critical numbers. Where is v prime undefined? If x is root 48, yeah? Or 4 root 3. You with me? Okay, so you've got your critical numbers and do your thing. My point is this, don't wuss out so much. I totally understand. You know, I don't do all this homework anymore, but I have a daughter who's doing this. So you're 11 o'clock at night, and you've got 17 more problems behind this. I understand wanting to cut corners, but there's a right way and a wrong way to do things, and you need the technique. Sorry. Go to, actually, let me remember. Go to number 9, please. 9 on the front. I am having a handful, this happens every year, I'm starting to get a handful of people cut corners on finding the slant. Does the old hand method find you the slant? In other words, is the slant y equals x? No, I did not teach you that, okay? Does this tell you there is a slant, go find it? Sure, but is the slant y equals x? No, this doesn't work, okay? Instead, what do you do to find the slant? You have to actually divide. If it's a linear divisor, can you use synthetic? Yeah. Could you use long division also? Sure. Okay. Next thing, when you do this, is it true, somebody circled this, y equals x plus 3 plus 8 over x minus 3 is the slant asymptote. Truth? Not true. What is the slant asymptote? Y equals x plus 3 is the slant. What is this? That's the equation, just in a different form. Okay, but it's not the slant asymptote. The slant asymptote is just y equals x plus 3. Clear? Okay. On the back side, 11 was something I checked. Tom's doing great. You're doing really awesome work. Everything's great there. 16 was pretty good. It was not too bad. I need to talk about 17. Now, technically 17 isn't till later in the book, set 98. But gosh, this is such a big idea of calculus and such a layup that I want to make sure you have it. So there's a shortcut to be had here, and most people did fine on A and B. If you have a check, it's always good. And if you have an X, that's bad. Most people have an X by C. So it seems like A went well because you said, well, heck, that's just the derivative of the antiderivative, which is just the function. And you said, except I know that X is the variable F standing. So 2x minus 2, most people did that well with what I would consider the shortcut, or the quick way. That's fine. How is B different? Yeah, down low, could I switch it to where it's up above? So it's an X up here? Sure, I could. That would mean that I get the same idea, the derivative of the antiderivative, but with the negative. So this answer is negative 2x plus 2. Then I had people then just go a bridge too far, and I had people say this is 2 sine of x minus 2. Now that's not true. Here's the thing. We're gonna go slowly through this and talk about where the shortcut comes from. Then by all means use the shortcut. But I intentionally made this integrable in case you wanted to do it what I would consider the long way, 3 steps. First, anti-differentiate. Leave the derivative, leave the limits, anti-differentiate. What's the antiderivative? T squared minus 2t. Cool. Now what do I do? Take the derivative or evaluate using the fundamental theorem? Fundamental theorem. By fundamental theorem, this is sine squared x minus 2 sine of x minus 3 squared minus 6. Do you agree? Okay. Now I take the derivative. The derivative on sine squared, what is it? 2 sine of x cosine of x. Minus the derivative of 2 sine of x is 2 cosine of x, and I think you'll agree the derivative here is nothing. So does it matter that this was 3? Would it have been any different if this was 72? No, it would have been the same because it goes away in every case. It doesn't matter what it starts with. All right, this said, if I take out a cosine, then I get 2 sine of x minus 2 times cosine of x. So you can see our theory was not quite right. We were missing something. What were we missing? Yeah, there's a chain rule component to this. Okay, there's a derivative of the inside function. When there's a function here, it's not just they cancel, boom, you're there. There's a chain rule component to this. And so that's why the cosine is there. Now, that said, it's important that you know the shortcut because there are some problems you can only do by shortcut. If, for example, you had something like this, 2 to the e to the x tangent of log of x, log of t. Okay? This is not integrable. You're not going to integrate that, no matter how much you try. And so if you try and do it what I would quote unquote call the long way, you're not going to get there. You have to be able to do the shortcut. So what is the derivative of the antiderivative shortcut stuff? Okay? Tangent of, that's log of t. Oh, x. Oh, good call. Yeah. I'm with you. I see where you're coming from. X. Yeah. Is that it? Times e to the x. There's the chain rule. Yeah. And yeah, you're probably right. That would be called x. You with me? Okay. All right. Those should be layups on the test. We'll practice them a little more, but it's not a big deal. But I did put it on there, so I felt it was worth going over. Alrighty, would you want to do a warm-up off the homework to get something on your paper? Or, okay, let's do a warm-up. Go to box, I believe it's 14. And you're proving continuity, but disproving differential.